agentic analytics, or basically anything using AI, you're moving at more of a conversation pace, right? If I was being you to have a conversation, and you ask me a question, and I take 10 minutes where I just think about it and say, it's not a very good conversation. Your pipelines will probably error out, and you'll waste tokens, things like this. So you want a sub-second kind of response for this stuff to work. Okay, hi everybody. I'm here to talk about data harnesses. So I've gone with a belabored pun, belay on, but I'm going to talk about getting data optimized and efficient and delivered in a way that really helps whatever you're doing, whether it's engineering, which we'll talk about later, or analytics, which is kind of more Dremio and my kind of area of expertise. So my name is Will Martin. I'm the data and AI evangelist at Dremio. I started out doing statistical analysis at the Large Hadron Collider, and since then I've spent about 15 years in the data industry, doing pretty much every role that starts with the word data. So I've been a scientist, engineer, consultant, analyst, and now I am specifically the data and AI evangelist at Dremio. And most recently I wrote the book, Agentic AI for Dummies. In terms of Dremio, I hear you ask, who are they? So we call ourselves the agentic Lakehouse provider. We are a Lakehouse provider, much like these more familiar logos here on screen, but there is one key difference between them and us. We have the better mascot. His name is Gnarly. He's very cute and much easier to personalize for blogs and events. Talking of cute logos and cute mascots, we also have this guy here. Is anybody familiar with this? Nessie? Correct, yes. So Nessie, sorry? Yeah? Yes, we based it. He's got a little Scottish hat. I don't know the word for it. It's arguable if he ever existed at all. Nessie in particular. But this is the mascot, the logo, for an open source data catalog. And Dremio created it, which not a lot of people make that connection. Other open source logos we are associated with are these two. Apache Arrow and Apache Polaris. So while we do sell a data lakehouse, we heavily invest in open source standards. So these three projects in particular, we have Apache Arrow back in 2016, which was co-founded by the same people who founded Dremio in the same year, which is a crazy popular in-memory format and now a transport format for processing columnar data. So great for analytics. There's a little stat there, 100 million plus downloads per month. That is specifically just the Python library implementation, just PyArrow. For some reason, they don't track the other libraries, but the stats are pretty crazy. Then in 2017, Apache Iceberg came out. We did not create this in any way, but we're big educators and users of this. Ways we contribute is I go and talk about it, and then we have engineers on staff who develop the code and contribute to the project. And then most recently, we have Apache Polaris. So this is another metadata catalog, similar to Nessie. And we launched this in 2024 with Snowflake. And originally, it was meant for Iceberg, metadata only, if you're familiar with that. But now it does other stuff. In particular, it does Delta. So if you want an open source Delta Lake catalog, this is a great thing to go for, rather than something like Glue. And to prove the educational aspects, we wrote the book on Apache Iceberg for O'Reilly, and we wrote the book on Polaris as well. So who here is familiar with data lakehouses? Should be a lot of people, but there's a little distinction. It gets confused with lakes quite a lot. So data warehouses are great for analyzing data, but they're a little painful for storing because of costs. And if your size goes up, your cost goes up quite a lot. So data lakes came along, which are great for storage, but they're painful for analytics. So the idea was to do the best of both worlds and bring them together. So lake plus house from warehouse is Lakehouse. It's as simple as that. And the idea is to combine the two together, and you get the strengths of both. So you've got the low-cost, scalable storage of, say, S3 or something like this, but you've got reliable ACID transactions you would only typically get in a warehouse. So you have this kind of layout here. You've got your lake and your compute. This would be a kind of data lake layout. To turn this into a lake house, you add two components. You've got a metadata catalog, which provides the right version of your data set from your lake to your compute. And then you have a metadata format, also known as a table format, and this is metadata about your data. Defines things such as your schema, your history, things like this. So it's great for rollback, great for just getting around the kind of issues with Parquet, which you may get in an analytics space, especially a fast-moving analytics space. So a general layout looks like this. Really, you have Iceberg data in some kind of lake. You've got a variety of catalogs you can be using, a variety of engines you can be using. So a data lakehouse is made in quite the same way you would make it in real life lakehouse. You find yourself a data lake, you add a little bit of structure in terms of a catalog and some metadata, and you have yourself a lakehouse. So a typical data lake, well, a general data lakehouse platform looks like this. You have your file format for storing your data in. You have your metadata format for storing your metadata. You have a catalog, and this acts as a kind of middleman and sends the right information you want to look at to your compute, which will be a query engine. So for Dremio, we look like this. We write data in Parquet because it's columns, and columns are fast. We use Iceberg. It's the only format we use. We've been using it for a long time, and now every other lakehouse in the space is using it, including Databricks. We have our own open catalog, which is powered by Apache Polaris. And we have our own query engine, which uses Apache Arrow. So on the right, you can see the OSS talk isn't a bunch of marketing. We actually invest in it and we use it. It's in every part of our stack because it's really performant. And it's good to use, and there's other benefits, which I'll talk about shortly. Okay, so what's this actually got to do with the topic of today? Right, we're talking about harness engineering. So typical layouts, if you're not using a lake house, you typically got something like a lake here. You've got some sort of data silos or your data in different places. Maybe it's another database, maybe a catalog, some object storage, God forbid an Excel, or you may be using a warehouse. So the old-fashioned kind of analytics space, sort of legacy analytics, it's a couple of years ago, you're kind of moving at an email pace, right? So you'd write a query, and it would take minutes to hours was seen as acceptable, right? So like you're emailing a colleague, they'll get back to you shortly, hopefully within the day, and that's fine for people, right? That's fine, it will work with this. It works if your data silos and you're pipelining it around. It definitely works for a warehouse. But for agentic analytics, or basically anything using AI, you're moving at more of a conversation pace, right? Even if you exclude sort of chat interfaces, right? If I was me and you to have a conversation, and you ask me a question, and I take 10 minutes where I just think about it and say, it's not a very good conversation, right? And your pipelines will probably error out, and you'll waste tokens, things like this. So you want a sub-second kind of response for this stuff to work. And it's not really a want, really, it's a requirement, right? You need this kind of speed. Because if you're working in the old style, stuff takes minutes or hours for a person, that's fine. I'll go make a cup of tea, I'll come back. But it's not going to work for agents. So things like a lake in particular isn't going to cut it for this kind of work. So today I'm going to talk a little bit about making a quality data foundation and a platform that kind of delivers this to whatever your needs are. So whether you're doing analytics or you're doing engineering, the needs are very similar. Your data needs to be accessible. So you need to be able to see your whole data estate so you can get the right, well, you need to see all the information so you get the full picture. So any assessments or analytics or anything you build is accurate. It needs to be understandable by whatever's accessing it, so you don't have to ask people, what the data means. And it needs to be performant, right? You need this conversational pace. And I'm going to put forward that the modern data lakehouse does this on all counts. And it also uses it with open source standards. So you're not locked into any vendor. You will see a few Dremio specific features. I've put a little gnarly there so you know what they are, but I'm mostly not going to talk about them because I'm not here to sell you Dremio. But this is what Dremio looks like. This is the full platform. So your data layer is at the bottom there, whether it's object storage, so your kind of lake, or any other kind of system you've got, warehouses, catalogs, you name it. You've got your execution layer, and at the top, you've got the things that are actually using it. But of course, we're talking about AI, so I've scrubbed BI off all of these slides because it's not relevant. But starting with AI, right, whether you're doing engineering or analytics, you're connecting stuff to AI. We integrate 3 ways. We have an agent built in if you don't want to build anything. So a big thing for analytics is the push for democratization of data. It was Databricks' slogan for quite a while. And this is for people who don't want to build and just want to use. They don't have to do anything. It's just a tab in the UI. There's the model context protocol, which everybody uses. Again, open source, so fantastic. And you've got the developer CLI. So if you're doing more programmatic stuff, doing stuff for terminal, you've got this. So the full breadth of how you want to connect your data estate to an AI, whatever you want to do it, you have it from very business focused to very technical focused. And I think for you, everyone here in this room, it's probably these two on the right that are more relevant. But it doesn't really matter, right? It's just, we connect to AI, but like, it just doesn't matter if you integrate, if what you're integrating with isn't very good. So the focus of the talk is this execution layer. So the things inside that make the Lakehouse, the query engine, the semantic layer, and the open catalog. So, and together these form the performant data harness. So really help you do your work with AI. So the catalog, straight up. So we have the Dremio open catalog. I call it the Dremio open catalog because Snowflake also have an open catalog. It is also powered by Apache Polaris. I'm not sure why we all decided to do that. It's a little confusing. But the idea here is Polaris is a great open source project. It came out of incubation in February this year and delivers all these great features you would want from a data catalog. And on top of that, we add a few things. We have something like Iceberg clustering, which is a nice alternative to partitioning. So what happens here is you cluster up similar values in your rows. So you cluster your rows by similar values, but you're not splitting up your data into partitions, physical partitions. So you get improved read performance, and it's a bit more easy to sort of understand and get your head around, especially for business users, which is a lot of people we go towards. Your table maintenance features, such as garbage collection and compaction, things that are essential for a lakehouse, and that everybody does. I'll talk a bit more about them later. And then there's also role-based access controls, which is part of essential governance. If you're doing this kind of thing, you can restrict what people are looking at based on roles, or even down to the very fine-grained level, rows and columns. So optimization is very common across the industry, whatever lakehouse you're using. So there's a thing called the small file problem. I'm sure probably a lot of people here have heard about it. If your data comes in and it's in lots of files, these files take a while to open, and this makes stuff slow and expensive to do. So you want all your stuff in one big file. That makes things more performant, and that's what it is. It just smushes things together into more compact files. Vacuuming gets rid of unused metadata, sort of from failed attempts or things you're not really using anymore. Gets cleaned up and saves you storage. And then you have something called variant shredding, which is a bit more recent. So is anybody familiar with Apache Iceberg or uses it? Okay, so with V3, the modern spec for Iceberg, there's a new data type included called variant, and this basically puts semi-structured data into a cell of your table. So this is something that's been in Delta Lake for a long time. It's been added to Iceberg, and in fact, it's been added to Parquet. So anything that runs off Parquet, any metadata format can use this. Part of the secret sauce for why Iceberg and table formats and lakehouses are so performant is because of something called predicate pushdown. You know, if you're looking for certain values, say you're looking at software developers aged 20 to 35, the metadata knows which files and which partitions, including those files, have the data you're looking for. But if you're shoving a JSON into a cell, you can't pull that information out until you have variant shredding. So this is a way of pulling out this nested or sort of compressed or structured information out of a cell so you can efficiently only open the partitions that contain the data you need and then the files you need. It's what makes things quick. And then the catalog also gives you end-to-end access control. So the big thing is governance, giving your users, and likewise any AI or AI agents, access to the right information. And it can do it at every level, right? So Polaris provides credential vending for the major sort of hyperscalers. So you get storage level access to anything inside your storage. And it goes all the way along to column and row level access through masking and filtering. So you can really tune stuff down specifically to any kind of user. And likewise, the agents are doing their work for them, or the agents you are training, or the agents you are developing, or the AI you're working with. Okay, second, sandwich in between, we have the AI semantic layer. The AI isn't really too essential here. It's not too different than what it's always been. But the idea is really that terms are subjective, right? So many business terms are not universal. If you talk to one company and then talk to another company, what they call a customer isn't necessarily the same. And then things that include money have to be calculated, like metrics, like revenue in particular is very different company to company. Then you get stuff like this, which if you've been a consultant or an analyst like me, you've seen a lot, right? I've got over 15 years experience. I have no idea what this is unless I talk to somebody. Claude's not going to be any better. It's trained on a lot of data, but it's not trained specifically on a company's data. So yeah, these definitions vary a lot, and you are lucky if your company just has one. So if you talk to, say, your customer support team, their view of what a customer is, their definition is going to be very different to your sales team. And a lot of times, these definitions aren't even in your tool, right? They're downstream quite a lot of the times. They're a lot of times in BI tools or separate spreadsheets, data dictionaries, things like this, things where your AI or any kind of downstream tool isn't really looking. Having it separate from your data is not a good idea. So you have no definitions. You're just going to guess, right? I would guess. Your model will guess with confidence. And then anything you get out of the process, any kind of analytics or anything you've engineered and built, you're going to have to question and drill down and figure out what you were actually looking at, what definition you were using. And if you have multiple definitions, it's pretty much the same, right? You're going to pick one thing. You're going to argue over whether you picked the right thing. And you still can't trust what you got. Right, it's the same problem. So really you need to consolidate your context into a single layer, a semantic layer, if you will, and put it in your platform. It just makes things simpler. You're connecting whatever system you've got downstream for your AI use cases. It's far nicer just to connect to one place. Keep your data and your metadata together. And just write down what a column actually means, right? What a metric is defined as, and then how your tables relate and how, which is really easy and a lot of places are doing because a lot of tables are defined with SQL, right? It defines how you derive a gold layer data set from a silver layer. It's right there in the SQL. And it actually is a source of truth. So you can ask your agent whatever question you like. So we have a question here which is laden with a bunch of very specific business terms. Q2 you would think isn't too different from one company to another, but we've just been bought by SAP and our Q2s are very different to each other. So it varies within a company. But you can see this as your prompt. You're asking your agent your prompt, it breaks it down to tasks, and with a semantic layer it can reliably take action. So it can go and find metric definitions which are defined in one place. It knows what your sales table is compared to the others because they're named properly or identified or tagged. And it can explain what the table means because it knows what the column definitions are. So this can be anything from very simple things such as a label, which is like just tagging your data set as something, to a wiki, to other more elaborate stuff like knowledge graphs. I think there's a lot of consolidation in the industry and talk about standardizing a lot of the semantic layer. You've probably heard of OSI, which is the Open Semantic Interchange. So this was launched last year with a couple of companies like Salesforce and Snowflake. It has recently turned into an Apache Software Foundation project called OSSI. The logo is a kangaroo. It's not very cute, it hasn't got a face, but the idea there is to standardize how to share semantic information between tools. But in terms of the implementation within tools, it can vary quite a lot still. We'll see what happens as the space develops. Okay, that's 2 to 3 features. The last component is the query engine. So Dremio does data federation. So hands up if you were born in the 90s. Okay, so we've been talking about tearing down data silos as long as you've been alive, but they are still around, and for good reason. People have kind of given up now on trying to tear them down. They're there for a reason. Data goes in and data comes out, so they're kind of painful to get rid of. So federation is the way it's at. So like with a Lakehouse, where you're querying the data where it lives, query your data where it lives in these other systems. So data federation, you can support multiple table formats, thanks to something like Apache Polaris, other data catalogs, thanks to something I'll talk about shortly, object storage, databases, you name it. The idea is to get the data accessible from one location, so centralize your access and your governance, but not physically centralizing your data, because that's the trap warehouses fell into. That's the pain point there. Down here we have reflections. This is a custom Dremio query acceleration feature, which I won't talk about. But we do caching. A lot of people do caching. We have query plan caching. So if you're writing data queries, your query is the same, but your data's changed, you can just use the same query plan, halves the amount of work you're doing. Likewise, we have results sets that are saved. So if you're running the same query, the query is the same, the data's the same, we just give you back the same results. And then the custom side, we have columnar cloud cache, which I always struggle with. I prefer C3. But the idea here is we just put data you frequently look at, frequently access, and we store that in the storage that's on your clusters, on your nodes, and it sits right next to the compute. So for some customers, you're getting like cost drop by 90% for something really basic, right? We're just using stuff that's not being used. So that's the performant data harness. Then we have the open data harness. I've talked about open software a bit, so a little bit more is these bits I kind of grayed out. So for us in particular, we have our own query engine. It's really performant. It's fun to use. Well, fun's a strong word. But there's other things on the market too. There's Kafka, there's open source stuff like Spark. And likewise, we support other query engines. So things like Snowflake, Athena, Trino, open source, Fabric, very much not so. But we permit full read and write access to the data catalog and the underlying storage, which is unique in the market. And we do this because we're using open standards, right? So at the beginning, I showed this as the sort of general layout of Dremio. I just moved it left a little bit. So this is the Dremio Lakehouse platform. But if you're using Iceberg, your platform can look like this, right? Specifically, like Parquet doesn't matter so much, but if you're using Iceberg, you have a whole range of catalogs you can use. You can use the Qt Nessie, you can use something else. There's quite a few Qt catalogs in the market, to be honest, and then lots of query engines. So you can really build the structure and the data platform that works for you thanks to these open standards. You build them for performance, you build them for cost, you build it for preference, or you build it because you've moved to a new company and that's what they're using and they won't budge. But really, it's up to you. You don't have to sacrifice performance by locking yourself in with someone. And this is thanks to Apache Iceberg, and specifically the Apache Iceberg REST spec. So this is how engines and catalogs talk to each other, basically. So all these engines on the left can easily talk out of the box to all these catalogs on the right because they use the spec. There's one or two caveats with some of the catalogs. There's some sort of write issues in some of them, maybe around Unity, a little bit around Glue, but you have a lot of options, and this is fantastic, right? It really blows open the space to build things you want to do if you don't want to just buy a solution. And it's really like in this comic in action, right? The entire modern analytics space is propped up by this. So even stuff like Fabric is using the REST spec. And now so is someone like Databricks, whose entire platform is built around competing format, Delta Lake. So in summary, yep, data analytics and engineering have the same data needs. Right? Data has to be accessible, so it needs to be widely available to everybody in your company, but also safely through governance features such as RBAC, role-based access control, and fine-grained access control that you can put at every single level, from the bucket to the row. It needs to be understandable, so you need rock-solid, definitions you agree on, so you're not leaving people to interpret stuff, because that's when things go wrong. And it needs to be performant, so you query the data where it is, you're not moving it, you're not cleaning it, and you're not waiting for stuff to read. You're not at the mercy of some IOPS pains. And all of this is delivered with really performant technology, which isn't tied to a specific vendor. It's thanks to open standards, in particular, Arrow and Iceberg, but there are others involved too. So you're not locked into Dremio or anybody else, but you can actually deliver the kind of infrastructure and the data delivery and data quality you need to send to whatever you're engineering or analyzing. And that's it from me. Thank you. We have time for questions if you want to do questions.
Yeah. Question? Got that.
Oh. Speaking to that. Since we are talking about AI native dev, I have to ask the AI question here, which is, you had MCP on there.
Yes.
And my question, of course, is token efficiency, right? So a lot of data queries could be, especially if they're being executed by agents, could be intensive. And specifically, the scenario would be, let's say that you have, let's say, cap table calculation or something, and you've got a nicely created, formatted version that's the right one. But then you also give the data primitives that are required to calculate, let's say, the cap. How do you prevent the AI from wasting time and tokens, trying to do it from scratch instead of like using the right, so deterministically selecting the right data path?
Yes, so part of the MCP setup is you've got your tools and prompts and templates to try and hem in performance or the kind of queries you do. So ours is kind of focused on analytics in that space. But in terms of MCP in general, the intent is it's more for builders, right? You're building your own setup, bring whichever model you like to the table. So implementation of guardrails and stuff like that, it's more on the builders in particular. So we give you discrete actions you can take and data sets you can access based on the credentials you're accessing with. But in terms of burning tokens, it's your problem as well, I'm afraid. But for the agent we have in the UI, that's limited more, and we have a very clear spend for that. Unless you bring your own agent for that, but again, we track the spend there. Yes.
Fuck you.
Oh.
Me. Shall I go next? Do you want to go next?
Oh, sorry, I was looking the wrong way.
I'll go next. Go on then. As I've started speaking. So yeah, one of the questions I had for you, if you look at what you have on your platform, one of the things I'm interested in is, and in general, not just in this kind of environment, you've just got the any agent. But what I'm trying to understand is, how can you expose some of the functionality and the capability so that the agent can understand it? So a bunch of metadata. So one of the things that we're building is the ability to have data agents. You have agentic data products. And one of the things we're trying to do is you've got a suite of agents up there, and you've got data agents which are accessing the data. But it has to understand how, any of the data that's in there and the metadata. How do you expose that so that the agent doing the work can understand what the hell how it works, if you see what I mean? Does that make sense? So let's say Claude is doing a query into the query engine. If it doesn't know anything about what it's doing, it's going to have to figure it out. How do you expose that data, and how can you have an agentic layer that can then feed further up to use that?
Okay, well, the query engine is just the execution. So in terms of our MCP, Claude would connect to that, understand the kind of actions it can take, like execute SQL. Analytics is nice and simple in that regard. Really, you're writing SQL for a lot of stuff you're doing. And the semantic layer provides the information it needs, so it can search for schemas and keywords in what you're asking for. And the semantic layer and vector search will help you find the right things, and it's next execute against that. But in terms of understanding a bit more specifically about what sort of tools do as well, the CLI does similar, right? You got the JSON structure comes back, and your agent or your model can understand what you can do and what to expect from certain actions, and then act accordingly.
Yeah, because I'm just, there's a missing piece for me. If I'm running a swarm of agents and I'm running a task, which is accessing data, composing a data domain, looking in a data domain, creating a data product, which is then fed into an agent to do a piece of work. What I'm trying to figure out is, how can you do that with what you have? So are you saying you've got MCP and you've got a bunch of endpoints that you can connect to, and that's how you would do it? So you'd have to construct it yourself. So what you're saying is it's all there, but you've got to construct this yourself. There's no more intelligent way of exposing the infrastructure upwards, so you don't have to do the work yourself. Does that make sense?
And the work you mean is creating a data product or understanding what's...
Well, not creating a data product, but the data product itself has to access a bunch of data. It looks in the metadata catalog, for example, and there's a bunch of other things you might want to do. At the moment, the way you're describing it, that you have to do that yourself, and compose it from your endpoints. So you have to work that out yourself and execute, where you don't necessarily provide pieces to work it out.
Well, it doesn't have to, right? You ask it to do something, it accesses through the semantic layer, so the layering's a little skewed here, really. Everything goes through the semantic layer, and it gets the context and the understanding of the estate, what data sets you have, what things are open to you as a user. It relates what you're asking to do to what's available. It knows what actions to take because of MCP. Like it knows you want to...
Okay, so you basically you have to... And how much metadata do you have around MCP? So all the endpoints that you've defined, one of the things that we're working on is being able to have a detailed description of metadata so the agent can consume it, so it understands, oh, this endpoint does X, Y, and Z, and it understands in a reasonable amount of detail.
Yeah, so it sounds like you'll be more interested in a CLI kind of approach, which is more structured and detailed. And the idea here is to give agentic workflows or multi-agent workflows, stuff where you don't want a person involved sort of overseeing and micromanaging. You give it that, and that provides information in a way that's more cost-effective and efficient for an AI doing its own thing. So yeah, I can share some links about the CLI if you'd like, or that's the way I would do it. It's better value for money and less work for you. Yes, sorry.
Thank you. Thanks for that. Brilliant stuff. How do you deal, or do you have the machinery for access control? And how do you make something like an agent, just obey the rules when it needs to? Because, there's all this uncertainty inherent in it. So you can just go and access something that it's not supposed to for the given user and get it back. I work in healthcare and genomics, etc. So a big problem we have with lakes and warehouses is just this, those people can see that, those people cannot see that, or just hell breaks loose. So do you have that machinery, or? Yeah.
So actually, we work with Genomics England. They're a big customer of us, and they're doing work using our platform. But actually, it's kind of basic. So I said earlier, the AI semantic layer is basically the semantic layer with fancy term on the front, and the agent access it's kind of also just repurposing stuff that's there, right? It accesses through a user account like your user account. So whether I'm querying information or I'm asking an agent to do it on my behalf, it can see the same.
So it's a pass-through machinery. Okay, thank you.
This guy at the front was waiting longer.
One already right in front of you.
You mentioned about the open semantic interchange. I was wondering how it relates with semantic web technologies like RDF, OWL. Is it built on top of those? Is it starting from scratch?
It's, I'm not too sure the answer. I'm not too familiar with the semantic web, but in terms of OSI, so I talked about Arrow actually. It's a good example up at the top. And I always think about Arrow when I think about it, because Arrow started out as an in-memory format, and then so they got every system using and sort of processing data in memory the same way, but then getting it between the systems was a pain, because it's columns in system A, columns in system B. You have to turn it to rows to get it across and back to columns. So then the transport format came along, and that was the next extension, whereas OSI, as far as I'm up to date, is the reverse. So it's the idea of a standardized format to share information between systems. And that's as far as it's really got. So JSON is the main one at the moment. There are issues with JSON, it's not very efficient. I think more specs will come out or get more interesting, but in terms of what it looks like when it's in system A and system B, I don't think there's any hard requirements on that. It's just, I think it really came out of trying to not vendor lock your business context to a certain tool. So, I'll research the web and find out. Yes.
Since you support federation, in my experience, it gets a bit tricky when you support different data sources. The agents are let me query all the data, and then you have to find out tens of different queries under the hood.
Yes.
Is there any tricks around kind of making the agents aware of the latency of the queries so that they can be more sophisticated about, let me do the fast access first and then do the federated calls like manually rather than offloading everything into the engine itself?
There may be in some tools, I know, sort of higher end, sort of federation-focused platforms do stuff like that. We don't so much. Instead, we have, so the basic approach is like, okay, if you want it to be fast, create a table in a data table sort of linked copy that you'll run from in your lake, and you get rid of the dependencies, and also you get rid of the sort of hammering the source system when you're running queries. The more interesting thing, the workaround we've done is reflections. So this is, Dremio will look at any queries you're running that are taking too long. So this will include other systems. And it makes materialized tables that will speed up those queries and then sub them in. So you can still keep, say, questioning your Hadoop system. Say it takes like a minute and 8 seconds, something like that. Dremio will make a table that gives you better performance, and it will sub it into your query without you having to change your SQL. And that will get you the performance you want without messing around. So quite a few of the sort of features we have and things are around making the user experience nicer for people who aren't technically minded. So you can optimize hands-on, but for some people, like, I don't want to.
So you rewrite the query plan on the fly?
No.
Or do I need to make the agent say there's a materialized table over there that you're supposed to be using?
You don't have to do anything. Basically, Dremio will look at anything that runs too slow and it will speed up those queries for you. So your SQL remains the same, and then when it's executing the query planner will sub in this other table and execute against that. It tells you it's doing it, but you don't have to do anything around it.
Thanks.
I think that is, we have to call that time there. But if we have any more questions, I'm sure we'll have time after as well. So.
Yeah, and I'm also around. So
Yeah, perfect.
Thank you.
Thank you.